Let's delve into an elegant geometry challenge involving a semicircle, its diameter, and an inscribed isosceles triangle. Imagine a semicircle with diameter line segment AB and an arbitrary point C positioned along its curved arc. We are given a point P that lies directly on the diameter AB, positioned such that the segment BP measures exactly 6 units. Furthermore, we connect point C to both A and P, forming triangle ACP. We are explicitly told that triangle ACP is an isosceles triangle where the side lengths CP and AC are perfectly equal, both holding a value of 14.7 units. Our objective is to determine the exact radius of this semicircle. To approach the solution efficiently, we can bypass complex cubic equations by leveraging the geometric symmetry of the figure. Because the point C lies on the arc of a semicircle with diameter AB, Thales's theorem dictates that the inscribed angle ACB must be a perfect 90-degree right angle. Next, we look at the isosceles triangle ACP and drop a perpendicular altitude from vertex C down to the diameter base AB, marking the foot of this altitude as point H. Because an altitude drawn from the vertex of an isosceles triangle naturally bisects its base, the length of segment AH is exactly equal to the length of segment HP. By expressing these segmented lengths in terms of the unknown radius, r, we can set up a system of relationships using the Pythagorean theorem. The altitude CH is shared by two distinct right triangles, triangle AHC and triangle OHC, where O represents the exact center of the semicircle. In triangle AHC, the square of the altitude equals the square of the hypotenuse AC minus the square of the base AH. In triangle OHC, the square of that same altitude equals the square of the radius OC minus the square of the central distance OH. Equating these two distinct expressions allows the higher degree algebraic terms to cancel out beautifully, collapsing the problem into a straightforward quadratic equation. Solving this final equation yields our definitive geometric dimension. The exact radius of the semicircle is 12 units.